Hi, in today's video, we're going to be talking about factorials. Now, what are factorials? So, have you ever seen something like this in mathematics? This stands for 3 factorial. The exclamation mark stands for factorial. So, what does 3 factorial mean? 3 factorial means the product of 3 and every number before it all the way till 1. 3 factorial is 3 into 2 into 1. Same way, 5 factorial equals to 5 into 4 into 3 into 2 into 1. 6 factorial would be equal to 6 into 5 into 4 into 3 into 2 into 1. So factorial means the product of that number and every number before it. Oh, wait 1 second. Okay. So as I was saying, a factorial means the product of that number and every number before it. So suppose you have n factorial. What would n factorial mean? It would be n times n minus 1 times n minus 2 times n minus 3, so on all the way till you have 3 into 2 into 1 basically. So if n was say 7, 7 factorial is 7 times 7 minus 1 6 times 7 minus 2 5 4 3 2 and 1 as I've written. Okay. Now suppose you have n factorial. Could we rewrite this as n times n minus 1 factorial? Because n factorial is just n times n minus 1 times n minus 2 times n minus 3, so on all the way till 3 into 2 into 1. And this is n factorial, and n minus 1 factorial is n minus 1 times n minus 2 times n minus 3, so on all the way till 3 into 2 into 1. So you can just tell that these are equal. So we can write this whole thing as n factorial, so as n minus 1 factorial. So n factorial could also be written as n times n minus 1 factorial. It could also be written as n times n minus 1 times n minus 2 factorial. It could also be written as n times n minus 1 times n minus 2 times n minus 3 factorial. It could be written as any, and so on. So I have a question for you now. Suppose you have n minus 1 factorial divided by n factorial. What do you think this would be? Alright, so we know n minus 1 factorial we can rewrite as n minus 1 times n minus 2 factorial, and n factorial we can rewrite as n times n minus 1 times n minus 2 factorial. These both cancel and these both cancel. All you're left with is 1 over n. So the answer for this is 1 over n. Say you have n plus 2 factorial, hold on, divided by n factorial. So what is n plus 2 factorial? N plus 2 times n plus 1, right, times n times n minus 1 factorial, and n factorial is just n times n minus 1 factorial. So n minus 1, n minus 1 factorials cancel. Remember, you can't cancel a factorial sign directly. The term with the factorial also have to be the same. So the final answer for this is just n plus 2 times n plus 1. Alright, say you have 2n plus 1 whole factorial divided by 2n factorial. Alright, 2n plus 1 whole factorial, 2n plus 1 factorial is 2n plus 1, 2n, 2n minus 1 factorial. And 2n factorial is 2n times 2n minus 1 factorial. These both cancel. All you're left with is 2n plus 1. And that's the answer. Okay. Say you have another, suppose you have another question. Alright. Oh, wait. My bad. Yeah. So if n, hold on. Okay, so as I was saying, if n plus 2 factorial equals to 60 times n minus 1 factorial, find n. Okay, so over here, how would we do this question? I wanted to pause the video and try it yourself. So, okay, so n plus 2 factorial can be written as n plus 2 times n plus 1. Oh wait, there's another thing to this question. Oh no, it's this much only, sorry. So n plus 2, n plus 1, n, and n minus 1 factorial. N plus 2 factorial we can rewrite as this, right? Is equal to 60 times n minus 1 factorial. So these both cancel because they're on other side of equal term, they're the same. So basically n plus 2 times n plus 1 times n equal to 60. Now there are two ways to solve this. One is the cubic method, the cubic equation. Now since the cubic equation is a bit long and you don't need it for this question, I'm not going to do it. But you can't use the cubic equation 2 for this. Once you evaluate this by one or two more steps, you can use the cubic equation. What I'm going to use is a trial and error method starting from the number 1. So if n was 1, this would be 1 plus 2 3 times 1 plus 1 2 times 1, which equal to 6. So n is not equal to 1. If n was 2, this would be 2 plus 2 4 times 2 plus 1 3 times 2, which equals to 24. So n is not equal to 2. Now what if we take 3? That would be equal to 3 plus 1, 3 plus 2 5 times 3 plus 1 4 times 3. What would this be? This would just be 5 into 4 20 into 3 60. So therefore we can say n is equal to 3. Since 60 is a small number, we can use the trial and error method and get the answer faster compared to using the cubic equation. Alright, our next question is 1 over 9 factorial plus 1 over 10 factorial equal to x over 11 factorial. Find x. So what we're gonna do is we're gonna keep 1 over 9 factorial the same. 1 over 9 factorial plus, what is this, 1 over 10 factorial is 10 times 10 minus 1, which is 9 factorial, equal to x over 11 times 10 times 9 factorial. See, if you take 9 factorial out from this equation, you will get, and this equation, so you take 9 factorial out from both, 1 over 9 factorial. So 1 over 9 factorial, if you take out from both of these terms, you'll get 1 plus 1 over 10 equal to, if you take 1 over 9 factorial out from this, you will get 1 over 9 factorial times x over 11 times 10 is 110. So we can cancel 1 over 9 factorial and 1 over 9 factorial. So therefore 1 plus 1 over 10 equal to x over 110. Okay, 1 over 1 plus 10 is just 11 over 10 equal to x over 110, and when you cross multiply, 110 times 11 is 1 0 is 0 1 1 0 1 1. So 0 1 2 1 1 2 1 0. So when you cross multiply, 10x equal to 1 2 1 0, therefore x equal to 121, and that's the answer. Alright, our next question is prove, so proving question now, that n factorial over r factorial equal to n times n minus 1 times n minus 2, so on to r plus 1. So prove that this equation equal to this equation. Alright, and the condition is that r is smaller than n. In this question, r is smaller than n. Okay, so since r is smaller than n, we can say n factorial is just equal to n times n minus 1 times n minus 2, and since r is smaller than n, it will occur somewhere in n factorial. So we can say r plus 1 times r factorial. Wait, since r is smaller than n, it will occur somewhere in the series as we're going minus 1 minus 2, so like that it will occur, r will occur somewhere in the series, and so will r plus 1. So we can write r plus 1 and r factorial in the series of n. N factorial equals to this. If we bring this r factorial over to our left hand side, we will get n factorial divided by r factorial equals to n times n minus 1 times n minus 2 times r plus 1, and they have certain numbers between them, and yeah, that's it. That's all you have to do, because we proved our original equation. This is what we had to find out. Okay, all right. Our next question is prove 2n factorial equal to 2 raised to n times n factorial bracket 1 into 3 into 5 1 into 1 hold on yeah 1 into 3 into 5, so on till 2n oh wait, till 2n minus 1. So you have to prove this is equal to this. How will we do this? I want you to pause the video and try it once, because this question is a bit complicated. Okay. What is 2n factorial? 2n factorial is equal to 2n times 2n minus 1 times 2n minus 2 times 2n minus 3, and so on all the way till 3 into 2 into 1. Okay, so if the number is 2n, so even if n was an odd number, it would become even because it's being multiplied by 2. So obviously 2n is even. If 2n is even, 2n minus 1 is odd. So what we're going to do here is we're going to separate the odd and the even numbers. Once we do that, we're going to get 2n factorial is equal to 2n, which is even, times 2n minus 2, right, times some numbers, and then you're gonna get 4 2, right? And on the other side, where you keep the odd numbers, you're gonna get, so this whole thing multiplied by the odd numbers, right? The odd numbers will be 2n minus 1, then 2n minus 3, all the way till, so what I'm gonna do here, if you can see in the question, the proving question, they've given 1 into 3 into 5, which is the same as 5 into 3 into 1. So I'm gonna just rearrange the final order. Instead of 5 into 3 into 1 and so on, I'm gonna make it 1 into 3 into 5. So what we've done here is we've separated the even and odd terms. Okay, so if we take out a 2 from this whole thing, what would we get? So you would get 2. Since 2 is in every term and it's being multiplied n number of times, we can take 2 raised to n, right? And if you take it out, you'll get n, and 2n minus 2 would just become n minus 1. This would become 2, that would become 1, right? Or let's just not keep the 1. Okay, so if look at our original equation, what do we have here? You can see that the odd side, which we've separated the odd and even, so the odd side we've already gotten, you can see over here, it's practically the same thing. So I'm going to rewrite over here. Yeah, so the even side will be this, times the odd side, which is this thing. So I'm going to remove 2 into n minus 3 here, because we don't have that in our original equation, and all I'm going to keep is 1 into 3 into 5 2n minus 1. That's what we have in our original equation. So we have to prove that 2n factorial equals to this. Alright, so you can see here that n times n minus 1 all the way till 2 1, that is what basically n factorial, right, inside the bracket. So over here we can rewrite the final answer as 2n factorial. Oh wait, we were finding 2n factorial this whole time, I hope you know, equals to 2 raised to n times n factorial. We can write this as n factorial, because actually there's a lot of numbers between n minus 1 and 2, so it's like n factorial times the odd numbers And there you have it, the equation which you had to prove. And yeah, that's it for today.